All right, everybody, going to go through the Unit 2 DES review here on Canvas, okay? Hopefully this helps. Please send me a message, Canvas inbox, if you have any further questions after this, okay? All right, so first go to our Canvas homepage. From our Canvas homepage on modules, you want to go down to Unit 2, and then on Unit 2, you want to click on the Unit 2 Factoring Review. Go ahead and hit Begin, and I'm doing this as a model student. So you'll see kind of what you would see if you were going to go through and do this yourself, okay? All right, so this first question says, drag each expression to the correct category. So some expressions do not belong in one of the four categories. Leave them in the possible answers area, okay? All right, so when I look at this, here it says a difference of squares. So a difference of squares. So I'm looking for a perfect square, which remember, if it's an exponent, that means it's got to be to a power divisible by 2, meaning an even number. And if it's a number, it's got to be a perfect square. So a number times itself gives us another number. So for instance, 9 is a perfect square because 3 times 3 is 9. Okay, so with that in mind, my difference of squares, b squared minus 121. Well, that's to a positive an exponent that's divisible by 2. 121 is a perfect square. I'm going to move that into my difference of squares. Okay, now I see x to the 6th plus 25. So x to the 6th can't be a difference of squares, okay? Because I can't do that problem because it's not a minus, okay? Now, this has a positive for the 25, which is a perfect square, and the 6, which is a perfect square. So that would be a sum of squares. Now keep in mind, that doesn't mean we can actually factor it. Remember, a sum of squares is actually prime, but we're just organizing them here. Okay, here I have 16x to the 2nd plus 9. So 16 x to the 2nd plus 9, both of those are perfect squares. That's a plus, so I'm moving that also into my sum of squares. Okay, x to the 8th minus 1. Okay, so x to the 8th, well, if it's to a power of 8, that's divisible by 2. Okay, and the 1 is also a perfect square, so that is a subtraction. I'd move that into my difference of squares. Okay, next up, I've got 27 x to the 3rd minus 125. 27 is a perfect cube, x to the 3rd is a perfect cube, 125 is a perfect cube. Since it's a minus, I know it's a difference, so I'm going to move that to the difference of cubes. Okay, now I see x to the 3rd plus 16, okay? Well, x to the 3rd, that's a perfect cube because it's an exponent that can be divided by 3. It's divisible by 3. But 16 is a perfect square, and it's not a perfect cube. So that can't go into any of these categories. So again, it said some expressions do not belong in one of the four. Leave them in the possible answers area. So that would just stay there. If you want, you could just move this guy over here so that then, we can deal with it later, okay? All right, x to the 3rd plus 64. Well, x to the 3rd, well, that's to a power of 3, so it's divisible by 3. That's telling me it's a cube. 64, also a perfect cube. So I know it has to go into the cube. Since that's a plus, it's a sum of cubes. Okay, next I see x squared minus 27. Well, this x squared is a perfect square, but 27 is a perfect cube, so I can't put it in any of the categories. All right, x to the 9th. So x to the 9th is going to be a perfect cube because it's to a power of that's divisible by 3. And then the 8 is also a perfect cube. We're adding, so this would be a sum of cubes. All right, lastly, here I see x to the 2nd, okay, minus 81. So x to the 2nd minus 81. Well, x to the 2nd is a perfect square, okay, and 81 is a perfect square. So this could be a difference of squares. Now, we actually have a complicated one, so just so you're clear here, the x to the 8th minus 1, this technically could be an answer for the difference of squares because that's to a power of 8, which is divided by 2 evenly, and 1's a perfect square. It also would be correct to be in the difference of cubes because x to the 8th over here, oops, no, sorry, my bad. It would only be correct over here, my fault. Okay, because that exponent is not divisible by 3. All right, let's go to the next portion here. Okay, so that would be my answer. That would be what I would put here for question 1. Okay, all right, so then as I'm going to move forward here, I'm going to take a look at question number 2. So now it says to match the binomial with its factored form. So here I see r to the 3rd minus d to the 3rd. So r to the 3rd minus d to the 3rd. R to the 3rd minus d to the 3rd. those are perfect cubes. So I need to go through the cubic factoring pattern. So I take the cube root of the first term, I keep the sign the same, I take the cube root of the second term. Now I do the first term times itself, so r times r is r squared. I multiply them together. When I multiply these together, I get negative dr. I need to negate that or cancel it. So I'm going to put plus dr. And then I do negative d times negative d, which is plus d squared. And then that's what I should get here. So I'm going to look for my answer choices here. So I need r minus d, and then r squared, and then dr. Now notice here this says rd. Remember when I'm multiplying, rd times d is the same as d times r, so this would be my choice there. Okay, so next I'm going to look at the n squared plus n squared. So m squared plus n squared. So that is a sum of squares. But something we should remember is we cannot factor sum of squares. Sum of squares is going to be prime. So I'm going to click my drop down here, and that is cannot be factored. Remember, cannot be factored is just another way of saying prime. Okay, next I see a squared minus b squared. So a squared minus b squared. That is a difference of squares. So I take the square root of the first term, which is a. I keep the sign the same. I take the square root of the second term. And then I need the exact same factor with the opposite sign. So I'm going to have a minus b and a plus b. So my drop down, that's what I'm looking for. And here we go. A plus b, a minus b. Last but not least for these is I see my a cubed plus b cubed. So I'm going to do the cube root of the first term, a, same sign, cube root of the last term, b. First term times itself, a times a is a squared. Multiply the binomial, a times b is positive ab. I need to negate it, so I'm going to switch it to negative ab. Then I do the last term times itself, b times b is b squared. So this is what I should have there. So I'm going to scroll over and try and find that. So a plus b, and then a squared minus ab plus b squared, okay? All right, so notice we were able to factor the difference of cubes, the sum of cubes, and the difference of squares. You cannot factor a sum of squares, so that's what cannot be factored, or prime. Obviously, that wasn't one of our choice options here. Okay, number 3. So this says type a 5th degree trinomial with a leading coefficient of negative 3. Make sure your trinomial is in standard form. Okay, so let's identify the things that matter here. We need a leading coefficient of 3. So remember what that means. That means the very first term needs to be negative 3. So we're going to put that down, okay? We need a trinomial, so that means 3 terms. So I'm going to just put some pluses here and a minus here, although that could be anything I want. And it needs to be 5th degree. So that means my first term should be to the 5th power. Now I could technically write it like that, which is what I would assume most of you would do. However, if I had to say x to the 4th y, that technically also is a 5th degree, because remember, within the term itself, you would add the exponents. And now, literally, you could have anything for the second 2 terms. I'm just going to put plus 2x minus 1. But these terms don't even matter. As long as you have a trinomial, 1, 2, 3 terms, with a leading coefficient of negative 3 and a degree of 5, then we're good. Remember, with the degree, you don't add across the term, so it's just that highest individual monomial exponent, okay? All right, unless obviously you set it up like this, in which case you would add them, but only within the one term itself. We would never do the 5 here plus this one. They're separate terms, all right? So again, that answer could vary in terms of what you put here, as long as you had what you needed based on the directions, okay? All right, number 4. So here it says drag each term to the correct position so the polynomial is in standard form. So to be in standard form, we go from highest to lowest exponent. So when I see the 5, that doesn't have an exponent or a variable at all. So that's basically a degree of 0. So actually, I know that's got to be last, okay? Now, I need to organize these from the highest exponent to the lowest exponent. So the highest one I see is x to the 4th. That needs to come first. Then I see the x to the 3rd. So I need to move that up. Then the x squared, then the 5. So the degrees here would be, for the 6x to the 4th, that's a degree of 4. For the negative 11x to the 3rd, that's a degree of 3. For the 2x squared, that's a degree of 2. And for the positive 5, that's a degree of 0 because it has no variable at all, okay? All right, number 5. Factor the polynomial completely. Select all factors from your list. Okay, here we go. So I see x squared plus 6x plus 8. So I need to set up my factoring. So 1 times 8 is 8. I need to add to the middle term, which is 6. So I need two numbers. I multiply, I get positive 8. When I add, I get positive 6. Well, that should be 4 and 2. So now I'm going to go x squared plus 4x, 2x plus 8. So you can see I bring that down, and I split the middle into those two terms. Now I'm going to take out the GCF, which here should be x, and then I get x plus 4. Here should be a 2. Again, I get x plus 4. So then you'll notice they match. So I write x plus 4 one time. The two GCFs form my other factor. So there we go, x plus 4 and x plus 2. Now I need to select those factors. So I'm going to do x plus 4, click, and x plus 2, click. So there we go. Okay, next. All right, so now it says to factor completely. So again, I'm going to factor this completely. So when I first look at this, I see a binomial. So my first thought is, okay, well, first off, my first thought should always be, do I have a GCF? However, beyond a GCF, I'm looking for, do I have 4 terms, 2 terms, 3 terms? What am I doing here? So when I have a binomial, my first thought is, do I have either perfect squares or perfect cubes? And in this case, I have perfect squares. So I'm going to follow that squares pattern that we had earlier. When we had the x squared minus y squared gave me x minus y and x plus y. The only difference here is I'm doing with the 36. So square root of 36 is 6. So I should have x minus 6 and then x plus 6. And then that is